All right, we are live. How was your guys' past couple of days?
Pretty good, I guess.
That's good.
Just working. So
It's been a pretty chillax week for me as well. Looks like we got 18 questions today. Well, 16 minus the two.
I've got to go into it now. Start it.
Awesome.
Okay.
All right, so for number 3, it says the total area under a density curve must equal, and then we're supposed to fill in the blank.
I was going to say Hamlet, because that's what I'm doing. You're doing what?
One.
Hamlet.
Yeah, one.
I said Hamlet, like hammer.
Okay.
Well, I said Hamlet, like, okay. Yeah. Yeah. I was saying.
I agree.
Under certain circumstances,
Like, oh,
the
she's
density
calling
curve
it Hamlet.
drops below the x-axis. So false, I believe.
False.
Yeah, but I meant to say homework, so that's what we should.
Can never be below. You can never even touch it. So
Yeah. A normal density curve is symmetric. That's true, I believe.
I would say yes, it is true.
yes.
Sorry, I'm just going to be turning off my mic a lot just because I'm over at my friend's apartment, so.
That's fine.
Sorry, girlfriend's apartment. They don't need to know details there.
She have to correct you.
Yeah. All right, then for the graph part, it says use the following image to answer questions 6 and 7. And it shows a graph. The area is 0.48413. Which of the following elements of the figure represents the z-score in this image? So the z-score.
Let's go back to that.
Yeah, I can't. Is it A? Or I don't know.
Yeah, I don't really remember this one actually.
What am I
Let's see here.
Took some different images.
It was. They gave me food. They fed me.
Pull it up here.
So x is the mean. And
Okay.
where is that you backward U symbol? Mean.
Isn't that
I have to memorize how to calculate the z-score.
man, I'm not finding it. Oh, there's z-score. Z-score probability. It's less than 5 part 1.
Yeah, I have a picture of it on my phone because I know I was going to use it.
Okay.
But
So is it A?
x.
If you just kept saying no.
So z equals the is it the probability?
I'm still reviewing.
Yeah, we're getting some feedback. Kelly, can you still hear me?
Yeah, I just have my mic muted. I'm looking also.
I was looking at the pregnancy one to determine how to define it. the probability. So it's x minus the mean.
Yep, divided by the, what was it? I just looked at it.
Is it divided by 1, or it's divided by the, or is it 2 times the?
I'll pull it up. I'll pull it up one more time. So z-score is,
I don't know, we have to memorize it first time seeing it, so.
I have no idea.
oh, okay, so it's x minus the mean all over the standard deviation. So
I believe it's A.
x minus the mean divided by the standard deviation. Let me go forward with this a little bit more just to make sure.
X minus.
Yeah, that's what it is. So we've got the normal. X is the normal distribution. The mean is that backward U symbol.
Yeah.
And the standard deviation is that that other symbol that looks like a 0 with coming off it.
Right. I was just reviewing z-score, and I don't know if A would be the z-score.
Z-score is just to determine if it's extreme or if it's not extreme. No, if it's out near the edges of the curve.
Mm-hmm.
Oh, I see.
So the shaded area is what it's trying to determine. That's what it's trying to say. So is A. So is 84%. So the area of 84% is the z-score. So it is A.
Okay.
Going with A?
Yeah, that makes sense.
Yeah, after I understand what z-score is again, yes.
And then which of the following elements of the figure represents the probability that the z-score will be greater than 1? So that would be B.
Yeah. Wait. Z-score.
So what C is? What's C labeling? Something below the? What's C?
I think it's labeling the 1.0.
Oh, the 1.
Yeah.
Which of the following elements of the figure represent the probability z-score would be greater than 1? Well, if we're going to pick...
It's got to be a B. None of them are greater than 1. It's never... well, although... Okay, never mind. That's wrong. It's got to be B.
Okay. Yeah, I think it's B as well. Okay.
But it's talking about standard deviation. It's not talking about you know, the whole bell curve equals 1, but it's not the same. Okay. Okay, so according to the 68, 95, 99.7 rule, what proportion of the data from the bell-shaped distribution will be within the standard deviation of the mean?
Okay.
Within one standard deviation.
Okay, I understand this. So you do the mean, which but the mean is 0. That doesn't make sense.
Well, we're not using the graph anymore. The graph's only for 6 and 7.
Oh, okay. One standard, it's going to be 68%.
One is 60. Yes, one is 60%. Two is 95.
3 is
99.7. Yep.
Yeah.
Okay, so for a number, we just put 68.
Yeah, for sure.
Okay.
Suppose the z-scores come from a standard normal deviation. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places. If the answer was, we understand that. Okay. I don't know what the normal applet is.
So if you go, you can go to on your phone. Well, anyway, there was a link to it in the video.
Oh.
But it's I've got the applet pulled up on my phone.
Yeah, I know what you're talking about. I'm trying to pull it up right now.
So it's saying that we put in for the area. Okay, 9. Okay, if the answer. Let's see when I see this random variable 1.
Hi, my name is Lena. I'm in the ward. I'm just letting you guys know about the sledding activity coming up. It's on Saturday, 5 to 7. Okay.
Okay, so we're only putting 3 decimals. Are we putting that in for the area? In that applet? It looks like that's what we would do.
Yeah, I think
0.389. Okay.
Oh, come on, computer. Oh. Okay, I'm just pulling that thing up.
I'm getting 0.86 and negative 0.86.
Wouldn't it just be one number? It couldn't be negative, the answer.
Well, we have to determine what they're looking for to see if it's a negative or a positive. So
I thought that it was 0.3173.
So we're only putting in that applet. Are we putting in the area as 0.389?
No, we're searching for the applet. That's just an example.
Yeah.
So,
okay,
here,
so
maybe I can share my screen.
On the side, there's a little screen share. It's the green button. If you have your mouse over it.
Is it working?
Yeah, almost. Yep. Yeah, it is.
Yeah. Okay. So right here, we're going between -1 and 1, correct?
Yeah.
It's giving me the answer of that right there.
Awesome. Yeah, I think that's.
Is that correct,
what I'm
though?
looking for.
well,
Yep.
What are you thinking?
I'm just gonna delete the other things. Delete all, empty all the boxes, and then put 1 and -1 to see what.
Okay.
What's the one?
That comes up at 0.1587.
Blonde hair. Oh yeah, that's right. Like that's true. She was. That's true. I like the one with the Botox though. They are cool. The best part.
So delete what you have in that top box, and then it'll run the.
She's so good in Ladies One. She's just the Botox one. The one.
Yeah, I messed up.
She's like.
Can you press enter again?
On my phone, I don't have to press enter. I just put it in, and that's what it.
I get my face again. I love that movie so much. Yeah. Does anybody have it? We should watch.
I don't know.
Start by deleting that area at the top. See what. Delete that, and then.
Yeah, just
it's putting in a calculation for some reason.
Remember what I had in my face?
Like
it's saying you have to be like you can do 0.7, and it'll change this. You should be able to change this.
Yeah,
to 1.
Incredibles and Monsters.
That to -1, and then it gives me that.
Yeah, I think that's the right answer. 0.317.
I don't know why mine does it differently, but mine.
It might just not run as well on a phone as it would on a desktop.
Oh, now I'm getting that same error that you had. The 0 has to be less than.
Well, not all. It could be
Yeah.
So 0.317.
all the Disney ones. I have.
Oh yeah, 7. Yeah, 3 decimal.
Right.
Thank you.
Let's go with that. 0.317.
So now I want to read 10.
Number 10, it says, suppose that z-scores come from the standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between the -2 and 2? So now we're doing the same thing. We just put a -2 and a 2 in instead?
Yeah.
Okay. So what does that bring up?
0.0455.
Yes.
All right, so 0.046.
Yeah.
And the same thing for
That can't be right.
Yeah, because it's bigger.
You're.
Oh, but we're looking at the blue.
Yeah,
the blue
that's right.
area, it should be 97.72. Oh, never mind. I gotta remove. What you can do is you click on the. Okay, so my.
Oh, I see what you're
0.9545.
Yeah, I got you. So you can, if you're looking at my screen, you can click these, shade them in. So it's 1, turn that off, turn that off, turn that on.
So the z-score is anything on the outer layers, right? That's what we determined.
Well, not according to what we put on number 6. We put A, blue, highlighted blue. But is the z-score the outer?
Yes, the z-score should be the outer and not the inner shaded area. So let's go back to. I'm gonna put in the 1 and the -1 again to see if that makes a difference.
So number 6 would be none of these.
Yeah, this is.
So for so now I have the same as what you have for 9. 0.3173. So for number 10, if I put in the 2 and the -2 with those 2 outer areas, now I'm getting. I don't know why it's. Oh yes. Okay, the probable area is 0.045.
Like devastating.
And if you round up 0.46 to the third decimal place. So we're sure on that though that z-score is the outer layer part of the graph.
It's a good question.
Yes.
I reviewed it and I wasn't really, I guess, understanding it very well.
Yes.
Yeah,
it is.
I'm not sure of it.
I'm certain it is.
It is?
Okay.
Okay. We'll trust you on that, Jason.
Okay, so going back to 6, we need to put D, none of the above. Correcto?
So which of the elements represent the z-score in this image? A would be half of it, but it. So, it's either A or none of the above. It's definitely.
I said none of the above.
Okay,
Okay.
that works.
So we're going on to 11. Suppose that the z-score come from the standard normal distribution. Use the normal applet to answer this question. What portion of the values from this random variable will be between 3 and -3? So it's basically you're just doing what we did with
The first two.
with 2 and 1, just making sure those areas are shaded
Yep.
on the outside.
So 0.003.
So
Yeah.
it's 0.0027, which rounds up to 0.003.
So just to review, for number 9 we got 0.317.
Yeah,
For number 10 we got 0.046, and then for number 11 we got 0.003.
That's correct.
Okay.
Correct.
Look carefully at your answers to the last 3 questions. What do you observe? The probabilities double? No. It follows the rule 68, 95, 97. That's the answer to 12.
The
Oh, yep,
values
yep.
match.
Yep, that's for sure.
Values match the 68, 95, 99.7 rule. Okay.
Yep.
All right, number 13. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.66, and it has a bunch of variables there. And the population standard deviation is 0.07. Use this information to answer questions 14 through 17. I think it should say 13 through 17.
Yeah. What proportion of the population have protein requirement of less than 0.6 grams? If your answer is a decimal. 3 decimal place.
Okay.
Okay.
So mean is 0.66. The standard deviation is 0.07.
Right. So you do 0.66, and then you do plus and minus for the 0.07 times whatever we're going to. One. It isn't 1350% is less than. If your average is 0.6, then 0.6. Oh, sorry. Never mind.
So how are we? My main question is how are we doing this calculation? What's this? The P and the kilo and the D. What they stand for. So the P is the protein. The kilo is the weight of people, and what's the D?
I'm just looking back and reviewing once more.
Is it the distribution?
That's what I'm thinking, but I.
Or the deviation?
Well, the deviation is
what we're calculating.
Deviation is the thing, like the little circle with the line. I think it's called sigma.
Sigma? Okay.
And then the mean, that U shape, is called a mu.
A mu, okay.
Yeah. Man, these are some hard questions.
Yeah.
I know.
Last week we were reading a graph.
I know, it's so easy this 2 days ago. Okay.
Why they're offering all these tutors to help you out. I was reading the emails. Tutors.
I know. I got a bunch of them too. Okay. Portion of population.
Oh boy. Oh.
Okay.
So what do we do with the negative ones? What do we do to calculate that?
I don't know. Doesn't make sense.
I don't know either. I'm looking it
Do
up
you
right
just
now.
subtract one, or do you?
It's an exponent, right?
Yeah, but if you look at it has a double exponent up above. -1 to the -1.
Yeah.
It could be that we just ignore those exponents altogether, just because like they might be, because they're the same in both the like variables of like the mean and the standard deviation, and it's also in the portion of population that we're looking for, 0.6 grams p. You know, it has the exact same things, same units. So I think what we're supposed to do is something as simple as taking the mean, so x minus the mean divided by standard deviation. So we're giving the standard deviation as 0.07, and mean is 0.66. So when we just take 0.6 to minus 0.66 divided by 0.07, does that make sense?
Yeah, it makes
makes
sense. I just don't understand why those would be there.
I found this here, just like let's see, how do you screen share?
You told me.
Standard deviation.
I found this
and
it's like that's that same formula.
so we're taking 0.66 minus 0.66 minus 0.07. Then we're dividing by what's the sigma one? The 0 with the.
So sigma is standard deviation, and that's the 0.07. So what you do is you do 0.6 minus 0.66, so you get negative 0.06, and then you divide that by 0.07, and you get a negative number. That can't be right. It's 0.857, negative 0.857.
Protein requirement.
Because you take x minus the mean.
Standard deviation. Yes, you divide by the 0. Okay, just a second. I'm having a problem visualizing this, and I can't. I have to write it down.
Yeah, that's what I'm doing right now.
So x is the standard. The standard deviation was 0.7.
Yeah.
Normal, the mean. What's the mean in this one?
0.66.
Here's my color scheme. I'm going to say you have 1 month.
And what's the other? What's x?
X is 0.06. I'm sorry, 0.60. Sorry.
Where is that in the question?
It is.
Oh, it's what we're looking for.
Mm,
Okay, it says the requirement is less the proportion of the population with the protein requirement is less than 0.6. So that's what kilos is. That's where the kilos fit in. All right.
Yeah, but like my color isn't really broken.
Minus.
I got
So yeah, I got 0.3428.
And you found that by taking.
You take, well, 0.6 minus 0.66 divided by 0.7.
So you have to take the whole thing on top divided by 0.7, right?
Can't really trust that color.
I think so. Let me just calculate it again. 0.6 minus 0.66 equals, so it equals 0.06, and then we divide that by 0.7. That comes out with, so if you calculate the top before you divide it, yes, it comes to 0.0857. So we're going to do 0.086.
So I have a task.
Okay, so I got the same as you. I hope we did it the right way. I just don't know what those negative exponents mean. If it's
Yeah, let me show you guys something real quick. I don't know if that's the right answer or not. I found this online. It's this little interactive calculator or graphing tool. Let me just show you here real quick. All right, so it's right here. So I put in the mean as 0.66 and the standard deviation as 0.07. And if you kind of like, it's not very intuitive just because like it's not exact. Well, it is exact, but it's too exact that you can't really find the number you want. So if you go to 0.6, which is, oh no, I went too far.
I see it controlled by your mouse instead.
There, almost there. Okay, so like 0.6 is like right there. So the z-score is 0.842, and that's close to what we got, right? We got 0.845 would be the exact calculation. 0.857. So yeah, like
8. So we got 0.8, yeah, 57, which is 86.
So maybe it is negative because it's everything less than 0.6. So it would be a negative number because it's below 0. So
no, we're looking at a percent. So I think you take that z-score, and because that z-score is doing the outsides of where you're looking at, right? And we just want below 0.6. So do you take that z-score and divide it by 2?
Okay.
Oh yeah, you would. Yeah,
we're just looking at the white on the left there, not the white on the right.
Right. So yeah, you would need to divide that by 2. So it'd be negative 0.429.
Why are you dividing by 2?
Because we're only looking at this area from here to here. We don't. The z-score calculates both. So like, I wish I could click it and make it.
Because in the calculation, they were saying it determines what you divide by what you're looking for. If we're looking for the 68th percentile or the 95th percentile.
Yeah.
Or the 99.7.
So I guess what Kelly's saying is that like we only want one side because it's everything below 0.6. So 0.6 is like right around here. We only want what's in the white to the left of my mouse. We don't want the other side because the 0.845 that we found.
So that means that we're dividing by 1 and not by 2. Because if it comes out to the second, you see, so you divide it by 1, not by 2.
Well, if you divide by 1, it's not going to do anything. But like, why would you divide by 1?
Because that's what it explains in the in the overview, when you do the 68th percentile, that's you're dividing by 1, and when you're doing the 95th percentile, you're dividing by 2.
That makes it more complicated, huh?
I hate this. Where did I?
And to get the 99.7, you're dividing by 3. That's I don't know. That's what I understood from the video's explanation, if I understand it correctly.
So what proportion? So I guess we're not really looking for a z-score altogether. We're just looking for proportion.
Yeah, if you look at your little, whatever you were looking at, it gave a percent at the top of the white area.
Yeah.
So if you put it on 0.6, that's giving the white area both sides. That's why I originally said divide by 2, because we're looking at the white area below that. I don't know. I don't understand it enough to formulate it, I guess.
No, but like it makes sense what you're saying. So yeah, if we go to 0.6, only problem is I wish I could change the x value to the exact number I want it to be. Let me see if I can find a better one. Hold on.
Okay, I'm gonna look also.
Okay, this one might be a little bit better. Let's see.
So for now, are we saying it's 0.086, or we're still trying to figure it out?
Yeah, we're still trying to figure it out.
Okay, Ken is famous on Instagram.
Because we know it's not going to be. We know it's not going to be a negative number. According to the question, it says what portion of the population would have a protein requirement of less than 0.06, and that whatever that calculation is. So it's saying we're picking about a little over 8%.
Right.
Of the population. But that just.
Okay, I think it's gone. How do your fingers do that? What is dispersing it? Yeah, that was a great problem.
And you know that the opposite is going to be true for whatever 13 is. 14 is going to be. You take 1 and you subtract whatever 13 is, and you're going to get 14.
No.
Oh
Oh my gosh. Cassie, get back here.
He's gonna call me on my cell phone.
Okay, so I think I really want to. Hey,
.6.
Oh, it still smells bad.
I'm going to do
Okay, let's do 1.96. I think I found something here. Hold on, I'll show it to you guys in just 1 second.
It can't stay in the middle after that.
Okay, I'm going to screen share again.
Pull it up.
Okay, look, check this out. So, put in the mean as 0.66, standard deviation of 0.07, and then it already gave me like the 1.96. I put that in there after I put these two values in, and then I changed the value to 0.6 to be below, and the results of the area probability is 0.1957. So that's this shaded area, and I'm pretty sure that's what we're looking for.
Yeah, that makes sense.
So 0.196 would be the answer.
That makes perfect sense. What did you say? 0.196?
Yes, 0.196.
Holy cow. Keep that open. We've got more.
Okay.
Could you send us a link to that as well?
Yeah.
You can just send it to the email.
Yeah, definitely. I will pull that up again. It's
I
called,
just mean to the calculator, not necessarily just to the screenshot or something.
Yeah, I'm sending you guys a link right now. I'll put it in the chat.
Okay.
Should see it on the side now. Okay, and then for the second question on this section, it looks like we have to do the same thing, but basically it's more than, so everything above 0.6. So I'm just going to go back to that calculator. You guys can do the same thing, kind of like, you know, put in the values.
No idea what just happened here. I clicked on that link and it like made that. Anyway.
Did not work?
Yeah, I can't see you guys anymore. All I see is that.
Oh, it worked on mine. I clicked on it with 2 fingers and opened a new tab. I wonder if you closed a tab.
Uh-oh, we lost Jason.
Can you hear me?
Yeah, we can
Yeah, I
still
hear you.
You just can't see me?
We can see you, but you can't see us.
Yes, I agree.
Kind of creepy, huh?
I'm gonna X this out, but I don't know if I hit the X that what happens.
That's all right. So on the second one, I got 0.804. Is that what you got, Kelly?
I haven't got it in yet. I'll just go with that.
Okay.
So you're putting 13. What was that again?
0.196.
0.196.
Yeah. So then for number 14, I did the exact.
Okay, so you were right, Kelly, because they're taking that 0.086 times. Well, no, if we just double it, then it comes. No, it doesn't. The number, it's not doubled from. Okay, never mind.
Yeah, I see what you're saying.
I thought it was doubled and it's not. So.
Okay, and then for number 15, I'm just going to put it in. It's going to be 0.7. It's less than 0.7. Yeah. So for number 14, I just switched it. I made it more. So obviously it's going to be a bigger number. And then for numbers, the following number, I can't remember what it was. Number 15, I'm just going to put in 0.7 and
so
make it below.
For 14, you're choosing. It should be 0.804.
It's 0.804. Yes, correct.
Okay.
And then for number 15, everything less than 0.7 would be 0.716.
That's what I got too.
Awesome.
I figured it out.
Cool. That was a doozy.
Yeah.
All right, who's got number 16?
So 15 is 0.016.
Just 0.716.
716.
0.716.
Yeah.
Yes.
Find the probability that a randomly selected person will have a protein requirement between 0.6 and 0.7. Hint: remember to find the area between the two values, shade to the left of each z-score you calculate, then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability that a randomly selected observer will lie between the two values. Give your answer in decimal, accurate to 3 decimal places.
See, with this nice thing that we found here, it actually gives you an option to find in between values.
Yeah.
So all you have to do is just put in the values. So it's 0.6 and 0.7 in between those two.
Yeah. 0.521. Correct?
0.521. Yep, that's what I got. 0.521.
That's my favorite little thing.
I really like this thing. Yeah, it's sweet. 0.521. Okay. Find the 35th percentile for the protein requirements for adults.
How do you do that?
This is going to be a little bit different, isn't it?
35 percentile.
So isn't the 50th percentile at 0?
That kind of looks like
50th percentile.
It should be right in the middle of that bell curve.
so much.
Top center of the bell curve should be 50th percentile.
Right, so we're looking for the 35th percentile. How do you even...
So what about...
So,
Black and white striped theme going? I guess so. Okay, so that looks like that.
35th percentile is what we're looking for. So
So will you use results area probability and put in 0.35?
that would be nice if that had an option on this, but it doesn't.
I'm going to go back to the applet and see if I can.
So I've gotten close. I got
Because on the applet you can. I thought you could slide that red line.
Okay.
Maybe I'm.
It's a little too hard to improve it. We're just being nice. No problem. Just not reacting.
to do percentile, I thought you had to know how many figures there were in the data set.
That's what I thought too.
So I don't understand how you do the 35th percentile.
I remember it being mentioned in the video as well. It's like. This is smaller.
I think it's me too.
Yeah. Oh my God.
Okay, I got the wrong video.
I love this homework so much. 8.625. 2. Okay, I'm going to play a video here. I'm just, you'll probably hear it. Okay, can you hear it?
No.
Okay, it says if you.
I took that picture. She just took the photo.
Maybe I'll just share my screen.
Okay.
If I can. I don't know. I don't know. Is there a way that I can do that? If I click on this X, is it going to drop the call? Or
What?
Can you?
What X?
I've got the red X in the upper left-hand corner of the Google.
Yeah, don't press that. That's gonna just
bad idea.
I don't know how to get the video back because I can't share my screen without it. What I can do is I'll take out and just turn up the volume so you can hear what it says. It's if you go back to the videos for this, can you hear me?
Yeah.
Yeah, I got you.
Okay, so if you go back to the videos, it's lesson 5 part 2 video at 6 minutes in. It's like 6 minutes and 8 seconds in. It says
percentile. If my height is in the 70th percentile, that means that I am taller in terms of males. And if I'm in the 70th percentile, my height, I'm greater than 70. I'm taller than 70% of all males. Okay. Conversely, that means I'm shorter than 30% of all males. So what I would do is that, say for instance, if I'm interested in getting a percentile using the applet, very first thing is what we would do is we click on the left side here because we're looking for all the people or items that's all the people in terms of height that I'm greater than. Okay. So say for instance I'm interested in the 40th percentile. So what I would do is that I'd go up here, type in 0.40.
okay. So the top center of the applet is where you type in 0.35.
Oh. Okay.
Do you get the 35th percentile?
Kelly, can you show your screen?
I'm trying to find that applet again. I had
Okay.
exited out of it. 1 second.
I thought you already had it, sorry.
No problem. Group meeting. Okay, where's, oh my gosh, we've got so many tabs open. Okay, I'm sharing my screen. Sharing?
Yes, it is.
Okay, that you're saying put 0.35?
Yes, in the top center. Yeah. And then that's how we get the 35th percentile. Okay, but the other things have to be calculated using. It says using the z-score under the left red line. Okay. You put the whatever your answer is for the calculation of x equals I don't know the name that U symbol.
Oh.
Plus the z times the.
So that negative 0.93 is our x value.
I think it's negative 0.935. If you look at the other side here.
Is there any way to like scroll more over? Is that as far as over as you can see?
That's all I can see. I can copy it. And
so negative negative 0.935 minus the mean, which is 0.66, divided by 0.07, which is the standard deviation. So let me do that real quick.
Oh my gosh, I'm so lost.
You're lost, Kelly?
Yeah, I with my tabs.
Oh, okay.
Sorry. Trying to find the homework.
So when I put that in, I got, what the heck? I got negative 22.786. If we round to 3 decimal places. I don't know if that's what we're looking for. Well, isn't that equation for to find the z-score that x minus the mean divided by the standard deviation?
That's for the z-score.
Yeah, that's how you find z-score. So is that what we use to find the 35th percentile?
No, it says. Well, it's got 3 steps.
Okay.
The first step was you click on the areas to the left. That's the first step in that curve. Then you type in the percentile number in the top center, and then you use that calculation, and you're typing that in. The bottom left, you make sure that left side is shaded. I'm gonna press play and see if it'll tell me more.
And the area becomes bigger. Okay. Then what I would do is that I would take the number that's next to the left.
So it says when we the shaded area becomes bigger because you're doing 35%.
I'm going to share my screen. I think I found a calculator for this dealio. Is it sharing?
Yeah.
Nope, that's the wrong one. Okay, percentile calculator. Mean value, standard deviation, probability, 0.35. Hit solve, 0.633. That's how.
Can you share your screen, Kelly?
Oh, is it not doing so?
No.
Oh, it says I am. It says you are sharing, screen sharing.
That's weird.
Yeah, and if I click on me, it shows that.
It's not coming through on our side. That's odd.
Here, I'll cancel it and do it again.
There we go.
Okay. Percentile calculator. Mean value, 0.66, 0.07, 35. Is that probability? 35%? I'm guessing. 0.63. That puts us in the correct ballpark. Because if you're average, it's going to be just below 0.66, somewhere right in this area.
Okay. The t value. Value t. Is probability the same as the percentile? I'm guessing it would be, right?
Guessing. So if I do 0.5, that should give us 0.66. Yep.
Oh yeah. Okay. So that makes sense.
That's awesome. How did everything go?
So 0.35 again.
Good.
Yeah. 0.35.
All the tables and chairs.
Oh.
0.6332. How many decimals should we put? It doesn't specify.
It's probably the same as everything else, just the 3 decimals.
So 0.633.
Yeah.
All right, and then it says for 18, it's the 80th percentile.
Okay. 0.8. Oops. 0.8. 0.719.
0.719. Okay.
That doesn't make a lot of sense to me. 63% is the 35th percentile, and 71% is the 80th percentile.
Your protein intake should be 0.6 and 0.7. The average is 0.66 grams. So those are actually in grams. 0.719 grams. 0.633 grams.
Okay. Yeah, it's still in the same units that we left it in. The grams p times kilograms to the -1 times d to the -1. Oh man. Well, I guess that's as good as we can do, right?
Yeah. I shared that link in the chat if you guys want to save it for.
Well, I'd like you to email both those to me as well, not just because I still can't see you guys. I can only see that other.
Oh yeah. Okay. I will send out an email to both of you right now.
Will you just include mine so I don't have to do that?
Yeah. Yeah, I'll get it.
Okay, thanks.
Definitely.
So for 16 we have 0.521, 17 0.633, 18 is 0.719.
Yeah.
So 17 0.633.
Yes.
I haven't put zeros in front of anything.
I just put 0.196.
Do you think the computer will mark us off?
I put zeros in front because that's the way they.
Yeah.
I put zeros in front of everything before that.
All right, I'll put zeros as well then.
I'll see you on Saturday.
Just make sure it doesn't change your answer.
Yeah.
That would be bad to put it.
If you go back to number 9, the way it asks you to do it,
yeah,
it puts a 0 in front.
Yeah, I gotcha. Okay. So do we want to go through our answers, make sure that I don't screw us up like yesterday?
Yeah.
I don't mind. I can read them real fast. Well, obviously the first two are true, and then 3 is 1. 4 is false. 5 is true. I have to figure out how to make my screen smaller again. Okay, 6 is none of the above. 7 is B. 8 is 68%. 9 is 0.317. 10 0.046. 11 0.003. 12 is the third one, which is 68, 95, 97.7. 13 is 0.196, 14 0.804, 15 0.716, 16 0.521, 17 0.633, and 18 0.719.
Okay.
Yeah, that's what I have. I'm hitting submit.
Good luck to us.
Not bad, guys. We only missed a couple. Well, a couple meaning 1, 2, 3, 4.
Oh my goodness.
So we were wrong on 6.
That's 80%.
Yeah.
Yeah.
6 is C.
See, yeah.
Mm.
I guess that
Applet deal sucked.
we did the applet. Yeah, the applet is what we got wrong. The things we used on our own were correct.
Mom.
I don't understand it.
Why would the applet? Yeah, that's funny. Like the thing that they provide us with is what makes us get the wrong answer.
Yeah.
So why would C be the z-score? Well, that's because it is the z-score. It's 1 and -1.
Yeah. Oh yeah. Yeah.
What were we thinking there?
For which one?
For number 6. 6 is C. It shows it right there. 1 and so C could be pointing to 1 and -1 if it wanted to. Okay.
Yep.
Well, good job overall, guys. I guess we'll just have to ask her about the applet and see what went wrong there, and just review some more z-score.
Yeah, it was. Well, you got to understand it before doing more. So I guess we.
All right, guys.
Perf. Have a good night.
All
Okay.
right.
See you.
Thanks. Bye.
See you Tuesday.